Welcome to Master Mathematics in Minutes. Today's topic is the geometric progression. We'll start off by defining what a geometric progression is, and we'll then cover a couple examples on how to describe a geometric progression. We'll conclude the topic with a summary. And finally, be kind and subscribe for more videos. So what is a geometric progression? A geometric progression or geometric sequence is a sequence of numbers where each term is the previous term multiplied by a common ratio. We will consider this visually. Consider the following geometric progression with a as the first term, a times r as the second term, a times r squared as the third term. Notice that each term is the previous term multiplied by r, and we'll call that the common ratio. And we'll label the first term as u1, the second term as u2, and the third term as u3, and so on. We'll denote the first term as u1 equals to a, and the common ratio is denoted as r. So the formula for the generic kth term is given by uk is equals to a times r to the power of k minus 1. Consider k equals to 2, where we'll have u2. Substituting k by 2, that gives us 2 minus 1, which is 1, and that simplifies to a times r, which matches that term. Say if we're looking for the fifth term, we'll substitute k as 5. That gives us u5. And 5 minus 1 is 4. And so that matches a times r to the power of 4. So there are a total of n terms in the progression. So n can be any number. It can be 5, it can be 10, it can even be infinity. Let's take a look at the first example. We're given the following geometric progression: 2, 4, 8, 16, 32, and so on. We're asked to find the first term, the common ratio, as well as the total number of terms. So the first term is 2, and so we have u1 equals to a equals to 2. And notice that 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And that gives us a common ratio of r is equals to 2. By counting the number of terms, we have 1, 2, 3, 4, 5, 6, 7. So there are a total of 7 terms, and that gives us n is equals to 7. Let's take a look at the second example, where we're given the following geometric progression: 128, 64, 32, 16, and so on. And we're asked to find the first term, common ratio, and total number of terms. So the first term in this case is 128. And so we have u1 equals a equals to 128. And so 128 times 0.5, that is 64. 64 times 0.5 is 32. 32 times 0.5 is 16. And so the common ratio is r is equals to 0.5. And by counting the total number of terms, we have n is equals to 8. In the third example, we are given the following geometric progression: 9, 81, 729, and so on. So the first term in this case is 9, so we have u1 equals to a equals to 9. And 9 multiplied by 9 is 81, 81 multiplied by 9 is 729. And that gives us a common ratio of r is equals to 9. And by counting the total number of terms, we have a total of n equals to 5. Looking at the fourth example, we're given the following geometric progression: 3, 15, and 75. So the first term is u1 equals a equals to 3. And because 3 times 5 is 15, 15 times 5 is 75. We have the common ratio as r is equals to 5. And there are a total of 3 terms in this progression. In the fifth example, we were given the following progression: 3, 15, 75 as the first 3 terms, and the final term is 4, 6, 8, 7, 5. Notice that this progression is incomplete. We're not given the complete number of terms. We're asked to find the first term, the common ratio, as well as the sixth term. So the first term in this case is 3. And so we have u1 equals a equals to 3. And because 3 times 5 is 15, 15 times 5 is 75, and so on, we have r is equals to 5. And to find the sixth term, we'll use the kth term formula from before, with uk is equals to a times r to the power of k minus 1. And we will replace k with 6 because we're looking for the sixth term, and with a as 3 from above, and with r as 5 from above, and we'll replace k by 6. And solving for that, that gives us u6 is equals to 9,375. So despite having an incomplete progression, we're able to work out what the sixth term is. To summarize, a geometric progression is a sequence of numbers, where we have the first term as a, second term as a times r, the third term as a times r squared, and so on. So each term is the previous term multiplied by r, and we'll call that the common ratio. The first term is a, and for this progression to be valid, a and r cannot be 0. We can denote the first term as u1 is equals to a, and we'll denote the common ratio as r. And for generic kth term, we have uk is equals to a times r to the power of k minus 1. And there are a total of n terms in this progression, and n can take any number, including being infinite. Thank you very much for watching. This is Master Mathematics in Minutes.